Okay, hello everybody. I hope you all can hear me just fine. Um, is this thing on? Okay, good. So good evening to all of you. Thank you all so much for coming and welcome to the Atlantic Council. My name is Peter Engelke. I'm a senior fellow within the Brent Scowcroft Center on International Security, and specifically within the Scowcroft Center, our Strategic Foresight Initiative. I am excited to welcome you to this evening's event celebrating the launch of Jamie Metzel's new novel, Eternal Sonata, a thriller of the near future. This event is the second in a series hosted by my shop, the Strategic Foresight Initiative, or SFI, that looks at the security, economic, and societal implications of the coming genetics revolution. So before we get to the meat of today's program, a bit of background on what we do here at the Atlantic Council. At SFI, we work to identify long-term emerging trends and explore their implications for policy and for strategy in the United States and among its allies and partners around the world. And in so doing, what that means is, in practice, we track key global trends, disruptive possibilities, as well as the interconnected risks that arise from all of the above. And what that means, in turn, is that our work takes us into really a wide-ranging set of topics, such as demography, the rise of the global middle class, environmental issues, whether we're talking about climate change or the food, water, energy nexus, urbanization, and of course the intersection of all of these things with geopolitics and strategic, sort of traditional strategic questions. If you have not yet done so, or if you're not yet aware, I'd ask that you take a look at our most recent publication, Global Risk 2035. I noticed, fortunately, that out in the hall there are actually hard copies of this document. This is a publication that was written by the director of the Strategic Foresight Initiative, Matt Burrows, who, as I'm sure many of you know, was formerly at the National Intelligence Council, where he wrote the last several global trends reports, the most famous of which was Global Trends 2035. And in this document, Matt takes us through basically how he sees the world and the intersection of all of these types of trends and potential areas of disruption that will have implications for all of us out to the year 2035. And of course, I did not leave out a very important subject in our work, which is technology. And the reason, of course, is that, as we all know, it's a bit of a trope to say so, but that technology is, of course, a driver of the future. And it's why we look at a set of emerging technologies that have enormous disruptive potential, ranging from computing to artificial intelligence to big data, robotics, and biotechnology. To give you an illustration of the kinds of work we do in this space, I am a co-leader of a project where we're focusing on why the United States is a leader in the area of technological innovation, and more importantly, how it can stay a leader looking forward the next decade or so. And so in the course of that work, we've done what we're calling an innovation road trip, or we're going out to places around the United States to help us answer the question, why is the United States a leader in the area of not just pure research and development when it comes to technology, but just as importantly, how do we get those technologies, if you will, into the commercial space? And so that road trip has taken us to places like Madison, Wisconsin, to Austin, Texas, to Boulder, Colorado, and of course the obligatory Silicon Valley, where we'll be heading next week. So what that means is that we're going to be taking the lessons and the insights from that road trip and writing up the findings into a report, where we will be releasing that report in the first quarter of 2017. And then, of course, of the various disruptive technologies that we take a look at, that brings us to really the subject of this evening's conversation, which is on genetics and on gene editing. And we regard this, of course, as being amongst the most important and impactful of potential areas of technical disruption, and is presumably the reason why all of you are here to hear our speakers this evening. And the reason why that is obvious, and that is because the kinds of revolutions that Jamie has been writing about and talking about for quite some time now have really, it's difficult to overstate, actually, I think, what the potential impacts are for all of life, and not just human life, but of course, especially human life. We don't exactly know how those things will unfold, but we do know that those things will unfold. I think it might be an appropriate way to characterize your work. And that, of course, brings me to actually introducing the rest of this evening. So I'd like to first introduce our next speaker, who is Tara Sonnenschein, former Undersecretary of State for Public Diplomacy and Public Affairs. During her career at the State Department, at the White House, and elsewhere, Tara has amassed expertise in foreign policy, programming, communication strategy, and public policy, and has had extensive dealings with business, community, and governmental leaders worldwide. She is the winner of 10 News Emmy Awards and other awards in journalism for programs on domestic and international issues. She is based at George Washington University, where she actively consults with the private sector, nonprofits, and multiple clients on media outreach, board development, and strategic communications. We are honored to have her join us tonight to introduce our speakers. Now, before I turn the evening over to her, I'd like to remind everyone that this event is on the record, not off the record, and therefore we have to mind our P's and Q's. So thank you all once again for joining us. We're looking forward to a stimulating evening, and so with that, Tara, the floor is yours.
Thank you very much, Peter, and let me ask you all to join in a round of applause for the Atlantic Council doing this event, because it's not easy to pull events together at 6 in the evening, so this event is going to wake you up. But a round of applause for Sam, wherever Sam is, and all of you who planned the event. I also want to, before he sneaks out, just acknowledge Congressman Dan Glickman and others from the Hill who are here, some Jamie fans and friends. I'm supposed to first tell you that the exit door, should there be an emergency, is there, but the only reason I'm mentioning it is because outside the exit door are copies of Jamie's book, and we encourage you, Anthony Garrett is waving his, we encourage you to buy this nightmare. Because what I want to say at the beginning is that this book is really frightening. And it's good scary in that it keeps you thinking, which is really what Jamie does for a living, is to keep all of us awake. And I am delighted to have the chance to roast him a little bit. So be patient, Jamie. Not his strong suit. Okay. So, first of all, I have to tell you, there are certain people in the world who have more energy than most. And this is a man who is an energizer bunny. So, here's what I want to say. How is it possible that you work, Jamie Metzl, for a New York-based, high-tension, big global investment firm and write sci-fi novels on the side? That's my first question. Second question, how do you have a resume that includes Brown University, Harvard Law School, and Oxford? Not possible. My third question is, how does someone who's worked on the U.S. Senate Foreign Relations Committee then survive the State Department, the National Security Council, the United Nations, and Cambodia? Okay, not possible. And how did you make room to run for a seat in Congress and literally run marathons? Also, not possible. But there's a lot in this book and this subject that seems not possible. But when you think about it, when you hear tonight from Jamie and from Richard Clarke, another scary guy with lots of scary scenarios, what they're doing is they're bridging science and national security. And these are two sectors that are often, they're not talking to each other enough. The scientists are hunkered down doing their science, and the foreign policy people are doing their foreign policy planning. And if you think about the intersection of those two circles, what gets caught in the crosshairs of science and national security. Oh, climate change, like tonight's storm. Zika, also affecting the state of Florida and other places. Nuclear arms control, chemical weapons, electricity grids, critical infrastructure, hacking, information technology, cyber, Ebola, bird flu, could go on and on. It's all science and policy. The reality is that science pervades our lives, our present, our past, and our future. So tonight, you're going to hear about how these two fields come together and how we make policy, draft laws, come up with regulations that deal with these new technologies. And one is genetic desirability and genetic enhancement. Can you imagine a world in which nations can use genetic manipulation of early stage embryos to create certain traits and characteristics, from height to IQ to personality? The good news that I will leave you with is that maybe this brave new world will unlock diseases, solve cancer, figure out Huntington's disease, Alzheimer's, Parkinson's. Maybe that genetic sequence will help all of us. Maybe we can engineer peace, engineer kindness, clone empathy, use sequencing to protect wildlife and endangered species, including us. But I ask you this, what if? What if there's a dark side? What if there's no values framework with moral, ethical, and legal boundaries? What if certain authoritarian regimes have the final say-so in who or what we produce? What will a genetic arms race look like? Will it make us more globally competitive, and competitive with whom? And finally, imagine an immigration debate that has genetically enhanced children coming in and out of a world without borders. People manufactured in labs, genetic codes being held hostage, genetic organisms slowing down our food or agriculture. And what I suggest you think about as we hear from the author of this book and from one of the leading national security thinkers on everything from cyber to infrastructure, what I ask you to think about, what's your role? What are you going to do to ensure the proper use and policies of this technology? Are you going to help govern the wild, wild west of genetic editing? So I come back to my author friend. He once said a novel is like a little piece of the author's soul laundered into a story. And when I asked him what the heck that means, he said, well, you know, exponential science is how we're going to see life differently when we understand biology to be as hackable as IT. Well, that really explained everything. So it is my pleasure to go off and teach a class, but before doing so, to turn this over to two of the really great thinkers in town, Jamie Metzl, Richard Clark. Thanks very much.
Thank you. I think I am here by my little thing, and you.
We have a mic.
Yeah, is that okay? We can also get you a lapel mic because we weren't sure about.
I don't think we need a mic. Can you all hear me?
I think we need a mic because of the video.
No. Okay.
Yeah.
Fine. And is it on?
Yes.
Yeah. Working?
Yeah.
Okay. Well, let's pick up where Tara left off, because She said as I came into the room, what's a guy like you doing writing novels?
Yeah.
I mean, with your resume, you could be doing any number of things. And you could be writing nonfiction books about this topic. You
Right.
could be making all sorts of policy recommendations. And why a novel?
So I have mine. Yeah,
You do, okay.
it's a great question, and this is not a setup, but it's connected to Dick. It's connected to you, because in the second Clinton administration, when I was Dick's White House fellow, Dick was talking about two big issues that he thought were really important, which were terrorism and cyber, and all these other people were saying, "You're crazy.
There was another reason for that.
Yeah, that this is just making work, that the big issues are China and geopolitics." And then 9/11 happened. The world changed because of all of the cyber issues. And then Dick, somebody who was in some ways marginalized by the mainstream and who just was constantly fighting, saying, hey, you have to pay attention to these issues. And everybody knows the memo that was on President Bush's desk on 9/11, written by Dick. And Dick always used to say that if everyone in Washington is focusing on one thing, you can be sure there's something 100 times more important that's being missed. And so I took that to heart. And so after I left working with Dick, I just was thinking a lot, well, what are those issues? And I kept coming back and back to issues of genetics and biotechnology. And so I started reading everything that I could. Then I started writing articles. Then this kind of crazy but interesting Congressman Brad Sherman called me and said he'd read one of my articles and wanted to do a hearing and around the article, and could I be the lead witness? So I started writing nonfiction articles. And everyone in this room probably knows you write nonfiction articles. Who reads them? People like you, people like the people who we know, and that's really important. But I thought deeply about, well, what are we talking about when we talk about genetic engineering and biotechnology? It's not just about policy. It's not just about science. It's about the future of our species. And that's something that's much bigger than just experts. It's much bigger than just scientists. And so how do we reach people? The average person isn't reading foreign affairs articles. And we're human beings. We have a long history of sitting around the campfire and telling stories. And so I just felt that I'd done this before, writing my first book was a nonfiction book about the Cambodian genocide, and then a novel set in the same context. And I thought, well, if I started writing novels, I could reach different groups of people and have them internalize and explore these very, very challenging issues in a way that felt more organic.
So you think you can tell the story better, you can grab people's attention better with fiction because you're not bound by footnotes and...
Well, certainly not bound by footnotes. And my friend Melissa Goldstein, where's Melissa? Raise your hand, Melissa, is here. And she always gives me like a librarian look when I start, because she's actually really knows this science very, very deeply. And so I certainly, the science is very real and it's very complicated.
Well, so
yeah.
One of the questions I get about my novels is, I read that, what was real in that novel and what was fiction? And so, that's a legitimate question.
Yeah.
People get confused.
And so that's why I set my books about 10 years into the future. Yeah. And what I like to do is think about, well, what are the technologies, the revolutionary technologies that exist today? And what are the implications of that? And part of it is 10 years a good period of time, so the fact checkers will have forgotten your book by then. But it's also, so for me, it's whether you get something a little bit right or a little bit wrong or whatever. I think
it's fiction.
It's fiction, but what we're talking about are the implications of these technologies. And so whether something like CRISPR evolves one way or another way, as Tara mentioned, it's going to evolve in a way that's going to fundamentally influence who we are as a species and what we are as a species.
So CRISPR-Cas9 exists and people are doing it. Where in the novel do you get into, for lack of a better term, science fiction? Where is it, hasn't happened yet?
Yeah, so everywhere with all of the technologies, I'm always thinking, what are the implications of this? And so with gene editing, and I think, does everybody here understand CRISPR-Cas9 and what it is? But the shorthand is it's a relatively, and certainly compared to the past processes, cheap and easy and quick way to edit the genome.
And it works.
And it works. It works with, it's not perfect. but the speed of improvement is unbelievable. It was 23 years ago that scientists figured out what it was, but it was only 3 years ago that it was figured out how to use CRISPR-Cas9 to edit the genome. And then it was only 1 year ago, in the first major application of CRISPR, that with gene drives, it was figured out how you could fundamentally transform all of life on Earth. And that's just first applications. There are many, many applications. So coming back to your questions about the science and the science fiction. So the science of CRISPR is real. The science of life extension is very real. And we're understanding more of the genetic foundations of aging, and a lot of it has to do with the regulation of cell growth between growth and repair. But I took it a step further, moving towards immortality. As I think you are, Dick, a Ray Kurzweil fan. I think we'll eventually get to immortality.
Probably not in Ray's lifetime.
But we're not as close. We're not as close as my book suggests. And Ray, he keeps saying, if you live 10 more years, you can live forever. But he's been saying it for 20 years.
He has. So, but your book takes it not only makes it happen in the reasonably near future.
Yes.
But it also talks about enormous life extension. We're not talking about adding 20 years in the novel, at least.
Yes.
We're not talking about adding 20 years to your lifetime. We're talking about, effectively, unless you get run over by a truck, immortality.
Right. And I think we will get eventually to immortality as a species. But I don't think it's going to happen in 10 years. I don't think it's going to happen in 100 years. It may not happen in 200 years. But the reason why I chose to put it in this novel is I want people to be thinking about where could this science go? And it's really challenging for us, and this is true for myself and I think for most people, that our brains are designed for linear thinking. If you're on the savannah and you've just 5 generations ago somebody climbed out of the tree and you're on the savannah and you're thinking exponentially, you're going to be dead very, very quickly, because you should be thinking linearly. Like, I saw a lion yesterday and it was scary, and so if I see a thing tomorrow that looks like a lion, I'm probably going to run. And that's the way our brains work. It was a very practical way to think. But right now we're in an age of exponential change, and so when it's very intuitive for people that Moore's law, the doubling of computing power every 2 years. So now we get it. We expect that our iPhones are going to get smaller and faster. But it's very difficult for us to understand that there is an equivalent of Moore's law. It could be even faster for biology. That, as Tara mentioned, I guess quoting me so I can say it again, that biology will prove as hackable as information technology. We have a long way to go. We have a lot more to understand about how to do it. But we don't need to invent new tools. The tools that we have, and we will invent new tools, the tools we have can do it. And we don't even know what new capacities are going to be created, because there's going to be an intelligence explosion, an exponential intelligence explosion with the intersection of our brains and artificial intelligence.
So CRISPR, I think, was invented in California.
Well, that's the debate.
Yeah, well.
Yeah.
I choose to believe it was invented by a woman in California. But clearly, the Chinese are putting a lot of money into this, and there are probably more Chinese experts, scientists, and engineers working on it than there are Americans, certainly. Much more probably Chinese government money going in than NIH grants and whatnot in this country. Should we be concerned about that?
We shouldn't be concerned about the baseline Chinese investment. We shouldn't be concerned that there are very smart researchers in China or anywhere who are focusing on these issues, because in the near term, the application of CRISPR isn't going to be life extension. That's not a primary focus. It's going to be disease eradication. It's going to be all of these things that are great. And the more people who are working on these problems, the better off we are going to be as a global population. But the thing that we should be concerned about is, and Tara mentioned this as well, is that we don't have a regulatory framework. We haven't had a global values conversation about how these technologies can and should be used. And so that's the problem, is there's a mismatch between the revolutionary technological capabilities and our understanding of them and the regulatory framework that surrounds them. And so in China, and my last book, Genesis Code, was primarily about this, where there's a lot of pressure on scientists to serve the state. There's a national agenda that's about national greatness and overcoming past humiliation. And while the laws are okay, the enforcement of those laws is minimal. And it's really dangerous because when we're talking about heritable genetic, gene therapy is one thing where it's just somatic. It's with the person and then it dies with you. But heritable genetic manipulation, that passes on through the generations. And so if that's happening, if there are areas, it could be China, it could be some island, it could be, as in this book, a ship in the international waters, that once that's part of the human gene pool, it's that way forever. So China's an issue, but the world is an issue. We need to have a regulatory and a values framework.
Well, because your novel is a novel, you don't have those task force, Atlantic Council Task Force 12 recommendations in the last chapter. We can guess where you come out on some of these things, but you don't have that explicit hit us over the head with it. So let's start with, where do you come out on the ethical issue of getting into the germline and not just fixing mistakes so that we can get rid of some terrible genetic disease or inherited gene, but improving human abilities?
Yeah. It's a great question, and I often skirt it because it upsets people.
But
I'm not going to. You're too good of a friend to let me get away with that. So what I'll first say is, step one, and this is one of my big missions in life, is that everybody, no matter who you are, where you are, what your background, whether you're a person of faith or any other kind of person, needs to be part of this conversation because it's about our species, and that certainly is my primary focus. Secondarily, I think many of us, but not everybody, certainly I am very, very comfortable with using gene therapies and other tools to cure diseases. At the third level, there is the issue of heritability, and that's traditionally been the boundary. In 2005, there was a UN General Assembly resolution saying that these changes should not be heritable. But now we've already crossed that barrier because the UK Parliament last year in February authorized clinical trials in mitochondrial transfer, which is basically the three-parent babies, and I can explain it afterwards if anyone needs, or you can ask Melissa. So that, and everyone was waiting for those first kids to be born. There was a few of them were born about a decade ago in New Jersey. But now we just have the story that a doctor from New York went down to Mexico, and so that already has been passed. And so these three-parent babies with a very small amount of mitochondrial DNA from the donor mother, that is heritable. And so then now I'm finally getting to your question. We are, the history of our species is that we have striven. When we had 25-year lifespans, nobody said, well, I guess that's it for us. When we were wandering around searching for food, nobody says that's it for us. We know that the sun is going to blow up in about 5 billion years ago. It would be suicidal for us to say, well, I guess that's that for our species. We have an instinctive imperative to grow and to improve and to survive. And I think that we're going to do it because of competition. And when people, if you have a choice, if you had to choose which of your natural embryos to implant, and you had two, and you knew one was going to have a 50-point higher IQ, and would live longer and have more immunity from diseases, and the other one would not have those things, you could say, well, I don't want to know. And some people do that, but a lot of people will want to know. And I think that that's going to become, over time, and it may be decades and it may be centuries, it's going to become very normal. It's going to be very expected. And as a matter of fact, people will feel like it's child abuse to not do it. And we need to do it carefully and inclusively, but I'm ultimately comfortable with that happening over time.
So that was a yes.
In other words, yes.
That was a yes. You, on the ethical question, you think it's okay within some framework, I assume,
yes,
in some regulatory framework, for us to think about improving the human species one by one, rather than just fixing defects.
And we've done that. In our history, we've done that.
So doesn't this bring us back 2,500 years to the debate about the gold and the silver and the bronze man, the layers of society, and doesn't it breed in inequality? Because some people, at least for a while, some people are not going to be able to afford this, and other people are. So, are we going to have the IQ in Westchester be 50 points higher than the IQ in Alabama?
Well, Melissa is from Alabama, so we already know that there's a very high IQ in Alabama.
West Virginia. Sorry.
Yeah. Oh, that's better. Anyone here from West Virginia? Okay, we're good. It's a real issue, and that's why I believe that the values framework is the essence of everything. Like, this technology is so revolutionary. I was giving a talk on this stuff in Mexico, and I said, I'm about to do a vote, and just think about your answer. And the question is, are you for or against fire? And people are thinking, well, I guess I'm for it for cooking, and I'm against it for arson, and it just is. And so this technology is, and it will get more and more powerful. But it has to be within a values framework, because the danger, and even if we have within a values, for everything that we have, there are first adopters. When I was in Bangladesh, when I just got my iPhone, I was thinking, God, isn't this terrible? Like, I have my iPhone. I have access to all knowledge on earth, and these poor people here, they don't have access. But now go to Bangladesh, and everybody has a $30 smartphone. So I think that this technology is going to spread relatively quickly. That doesn't mean evenly, and there will be inequalities. And why will it spread quickly? Because we're going to eliminate a lot of diseases at first, and those diseases are expensive, and so societies will have an incentive, and because people are going to want it. And so I think that again, it's all about values, but it will normalize over time.
So there's obviously a governmental role here we've been hinting at.
Yes.
Does the current government, does the current Congress have a clue about this issue?
No clue whatsoever. Yeah. And that's the problem. I mean, that's the problem. You know, every day you open the newspaper, and what are usually the top 2 or 3 stories? I mean, you focused for years on terrorism. Terrorism is extremely important. But 1,000 years from now, no one's going to remember ISIS. Everyone is going to remember when we figured out how to manipulate the human genome. And so so there are these issues. It comes back to you and what you've been saying for decades, that there are these really important issues that are so big and they're so challenging that we ignore them because it's like you can't get your arms around them.
So if we threw this issue before the current Congress, wouldn't it just be like the abortion debate, only more so?
Yeah, and the danger is this getting swept into the abortion debate. I mean, I shouldn't say this because I give people ideas, but why is it that we have protests in front of abortion clinics and not in front of fertility centers? Because if you believe that life begins at conception, there's a lot more killing that's happening at fertility centers than happening at abortion clinics. But it's normalized over time, and people got used to it, and a lot of people who are in the pro-life camp are having babies with IVF. And so there's a real danger that there's an argument, I don't believe it, but there's an argument to be said, well, let's not say anything. Let's just let this technology develop to such a level where people say, geez, my uncle had cancer, and they used gene therapy and gene editing to cure that cancer, and maybe that's going to open my mind to that. But at the same time, again, this is about the future of our species, and I just think that the cost of not being inclusive. And so coming back to what you were asking about government, I think the government is not prepared. There's all kinds of ideology, but we have to start grappling with it. And that's why an inclusive conversation, in my mind, is where we need to start. It didn't happen in the beginning of the GMO experience, and part of the reason was because scientists thought, God, this stuff is so great. We're going to be able to eliminate all these. We're going to feed people. We're going to eliminate diseases just by having small changes into food. Who would be against it? Yeah, right. But they didn't bring everybody together, and now you could do all the public education in the world. You could have every Nobel Prize winner, which is happening, say there's nothing wrong with GMOs. Forget it. It's too late.
So this was the third novel?
Yes.
Is there a fourth?
Yes.
Yeah?
Yeah.
Is our Kansas City Star reporter
going
to reappear?
I was thinking of starting afresh, and then these characters started
they're alive,
coming at me in my sleep, and so there is a fourth.
Yeah. Just happens to be Kansas City.
You know, you got to write what you know. I'm a Kansas City boy.
So the other question that is always asked of authors of novels is, so when's the movie coming out?
You know, it's funny. I was in Arizona. This is just like bragging, but I was in Arizona 2 weeks ago speaking at this Google Zeitgeist conference, which was unbelievable. But I went on a morning hike at like 5 in the morning with the publisher of St. Martin's Press. My first 2 books were with St. Martin's. And he was saying that, maybe I'll put it up for a poll. How many books do you think are published in the United States every year? What's the guess? Just shout it out.
The novels, fiction?
Just all books.
I don't know, 10,000?
10,000, 20,000? Very good. Anthony Garrett gets the paid book. Yeah, 200,000 books. And every single person, their friends come and say, that was awesome. When's the movie coming out? When are you going on Oprah? When are you going on Terry Gross? When are you going on NPR? And everyone should, if you like what you hear, you should talk to Carol afterwards. So I would love for there to be a movie. If any of you we have one person here who looks like a movie star, Rebecca, but I would love it. No plans as of yet.
All right. Do we have time for? You said let's have a debate. Let's start asking the questions. Do we have time for that? Shall we?
Yeah.
Anybody?
Absolutely.
You want to start?
Yeah.
In the front row. Right here. You.
Yeah, it's coming. Here. No, it's coming.
Yeah, it sounds like if you're doing this with embryos, what about the argument of trying to make a master race?
Yeah. So the master race eugenics is very real. And I think that we can't shy away from the implications. It's easy to say, well, this is about curing disease. It's about living longer. It's about all of these things. But it's very, very sensitive. Eugenics, as you know, it was very popular in the United States a century ago. And I speak a lot about these topics, and invariably I always will have somebody who will say, hey, I have a kid who has Down syndrome. If you're saying that we're going to have embryo selection, IVF and embryo selection in the future, and parents aren't going to select to implant kids who have Down syndrome or Huntington's or whatever, aren't you implicitly saying that my child has less value than a child who doesn't have that disease? And I think that's a really substantive, serious argument, and we need to take it seriously. And so, yes, there is that history, and that's why in Germany, for example, the environment is much more restrictive on embryo selection. And we can't shy away from, we can't pretend that there aren't those implications, because we would do so at our own peril.
But if I understand where you're coming from, it's not a master race because it's available to everybody. And you're suggesting that the price point comes down, and that it becomes normal, and it's the norm for everybody eventually.
That's what I would like to see, and that's how I would imagine it happening. But I think we need to be honest that things happen differently. Sometimes there'll be, in evolution, you get some little advantage, and then you leverage that advantage into a big advantage. So I think that what you described and what I described, that's the ideal scenario. But there are other scenarios, and I think that we can't shy away from thinking about the best case scenarios and the worst case scenarios, because if we don't have an inclusive conversation that includes both, people are going to feel they're being snookered, and they'll have a very raw emotional response to that.
Yeah. Yes, sir. On the aisle here.
Thank you. People have been talking about this for quite a while. Back in 1968, John Brunner published Stand on Zanzibar, where one of the subplots was a major Asian country using genetic engineering to create a super race. So it's not a new idea, but the problem is morality keeps moving. You know, in 2004, the presidential election was all about preventing same-sex marriage, and today it's considered perfectly normal.
Yeah.
So how can you predict the future of morality when something hasn't even been implemented yet?
Well, you can't predict it. That's the point. And my thing is that you can't predict it. We don't have an answer. What we need is a process that will morph and evolve and bring people in so that we can come to an answer, a collective answer that people feel represents them, and people have been socialized to it over time. So I don't think there's no one answer. And even if we miraculously were to get an answer, it would change the next day, because everything is constantly in a state of flux.
But also in 1968, it was science fiction. And you could argue, really not anymore.
Yeah, I'm barely in the science fiction camp. Like I'm kind of in the science fiction camp, so it's in the future.
So
but
in Barnes and Nobles, is it in the science fiction?
No, it's in fiction.
That's right.
Yeah.
That's right. Anybody over here in the back?
Yeah. Yes, hi, Joanna.
Hi, Jamie. Thanks for that good talk. I have a question, which is sort of a Washington question, because let's go back to the regulatory needs of this issue. I'm not optimistic that you can get regulation with a Congress that has no interest in passing or approving regulations, or agencies that have people who are not going to be involved in it, or just the whole polarization of ethical issues in general that we're seeing. Will other countries take the lead? This is a transnational issue. This is an intellectual property issue. Who will become the rule makers on this?
And it's a great question. Maybe I'll answer it narrowly and then broadly. And I really want to hear what Dick says, because Dick knows 100 times more than I do about how the U.S. government functions.
Or doesn't.
Huh? Yeah, exactly. There you go. No, so let's take mitochondrial transfer just as an example. And so mitochondrial transfer, just to simplify it, mitochondria are the power packs of the cell, and they exist. If you think of the cell as the nucleus and the cytoplasm, the mitochondria, and think of that as the egg yolk and the egg white. The mitochondria are in the egg white. Women pass their mitochondria to all of their children. That's why you have the mitochondria of your mother. But women who have faulty mitochondria pass mitochondrial disease to their kids in different levels. And because the kids don't have these power packs of the cell, the parts of your body that need power don't have enough. And that's starting with the brain. So it's very dangerous and deadly. So there are two different processes for eliminating forever mitochondrial disease when women who have it are having children. One is by swapping out the egg white from the egg, and the second is doing the same thing for an early stage embryo, again, because it's always the mother's mitochondria. So it's in the US and the UK, this process is being considered. In the US, it's happening under the FDA as purely an executive action about licensing. In the UK, there was a national, through the Human Fertilization and Embryology Authority, there was a national engagement process with experts meetings and town hall forums and public dialogues, and it happened for 3 years. And at the end, there was a full vote of both houses of parliament, which ended up authorizing these clinical trials. So that's two different models, the US being done in the executive branch, because if it goes out of there, it gets caught up in abortion. The UK, that was broad and inclusive. And then, as I mentioned before, and then there was Mexico, which didn't have any law. And so a doctor from here just went to Mexico and did it without any regulation. So there will be a mismatch. There's going to be a hodgepodge of different things. And I think it's going to require a lot of different entities. Some of them are governments, some are non-governmental organizations, foundations, motivated individuals to really come together. But ultimately, we're going to need some kind of international agreement. And the challenge is that if it's too lenient, it can't be so lenient that it allows things that everybody will be uncomfortable with. And I think that means very uncomfortable with. But it can't be so restrictive that countries like the UK or even the United States or Singapore or others, or China, who recognize that the future of healthcare is connected to all of these issues, will sign on. And so that's the balance. But it's going to be, for a while, a hodgepodge of different things. It's not a satisfactory answer. Dick, what do you think?
No, I think that's exactly right. The government today has two ways of regulating this. One is through the FDA's existing regulatory authority. They don't need any new legislation. The other is through the NIH grant program, because if you're going to do experiments in this area, you probably need federal money. So that's as good as far as it goes. But then let's imagine that what happens in this field is what happened in space. And you get the private billionaires going in and starting their own companies without government money. And if the government regulates against it, they move to Mexico. Yeah. Or they move to some country where they're allowed to do it. There's no international regulation that has teeth. They're international. There's the UN resolution. There are international scientific conferences and whatnot. But none of them can say to the Bahamas, if you don't adopt our international standard on this, something's going to happen to you. And so no matter what we do here in the United States, it's likely to happen somewhere, I think.
So, yeah. So I'll just repeat the question. So Carol was asking, what are the concerns of people that what happens in Mexico? So,
What happened in this particular?
yeah. As I mentioned before, many people are very comfortable about heritable changes to the genome. So it's a gene therapy. It's just for you. Heritable change. It's forever. So this mitochondrial transfer treatment, mitochondrial donation that happened in Mexico, 1,000 years from now, 10,000 years from now, the descendants of this woman who had the child in Mexico, they will have different DNA, just this small amount, than they would otherwise have had. And so the fear among many people is that crossing this line of heritability opens the door to all kinds of heritable changes in the genome. And it will be that people have all kinds of heritable genetic diseases. There are about 10,000 known Mendelian diseases, which are just single gene mutations diseases like Tay-Sachs and sickle cell and Huntington's. And a much smaller percentage of those, we understand how the mechanism works. But if somebody is carrying around some disease and it's going to be a lottery, let's say it's Huntington's, for their kids and grandkids and great-grandkids, I think a lot of those people, when it's available and safe, they're going to want to make that genetic change. So it'll start with one thing. And many heritable genetic diseases, people are going to want to eliminate forever. And the fear is that there's a slippery slope. And so the people who are calling for caution, including many, many scientists, are saying they're not saying don't do it. They're saying let's have a framework for thinking about it before we do it. The old-fashioned slippery slope.
It is a slippery slope. Anybody over here? Yes, sir.
Yeah.
I have a question. I hope this doesn't take too long to ask. It's about the intersection of other trends in technology and what we're talking about here. And specifically, I think if you went back a couple hundred years ago and imagined what would make a country or some race of people stronger and give them an unfair advantage, the focus might be on strength, physical strength. And now with new technology, that's not what makes an army strong. It's not what makes a nation strong. Even 10, 15 years ago, you might have thought about memory as being a really valuable trait. But now with the internet, it really isn't. And if Kurzweil and others are to be believed, we're really going to see a melding over the next century between computers and artificial intelligence and our own brains. It makes me think that IQ, at least the way we're currently conceiving of it, will be a less important trait in 50 or 100 years. I'm curious about what traits you think, other than just pure sort of longevity, will be valued in the far future as opposed to, say, the near future of the next 50 or 100 years.
It's a really great question. Just because you could go back at any point in time and you could say, what is really important now? Like if you could make everybody like a really awesome spear thrower, wouldn't that be great? Imagine we'd be feasting on buffalo every night. And there were times where people were saying that whatever, being like a really good farmer was relevant, and it's constantly changing. And so there's a real danger. And the diversity of our species has been our greatest protection forever. And we're going to need that diversity. So there's a real, just like with GM crops, they're not harmful to eat, but there's a danger of monoculture. And with humans, who knows what kind of skills we may need in the future. So it's very, very difficult to predict. And so definitely we need to have diversity. But then it's just the question is if you're an individual parent and you're making a choice about your kids and you're thinking, well, IQ or mathematical ability, what are these kind of general capabilities? And one analog is when we're just even thinking about artificial intelligence. Right now, we have these specific intelligence. There's a big debate of can robots get to general artificial intelligence. So will there be a value of human intelligence? Will there be, I think that we're going to definitely merge with machines, but there'll be a human piece of that. And so I don't know. I mean, that's just a rambling guess.
So you believe in the Borg is what you're telling us?
I definitely.
Resistance is futile?
We are already the Borg. I mean, we are already. Who is smarter, me and my iPhone or Stephen Hawking or whatever? It's just like if my iPhone gets 5 feet from me, I start to have a nervous reaction. The iPhone is an extension of my brain. This technology will move inside of us over time. It's not going to be something that we carry around. And so if technology is inside of you and you're interacting with it all the time, is it you? Is it not you? Who knows and who cares?
Yeah, in the middle here.
I was going to address what you mentioned earlier, which is other countries. And in fact, Peter Nygaard has announced this summer at the, I was telling Jamie about the Radical Life Extension Conference in San Diego this summer. He actually had legislation passed in the Bahamas to set up a stem cell plant. And so there were so many people at this conference who are, the cat's already out of the bag, and the question is, you can't regulate it at this point. You've got telomere experiments going on in the Fiji. There's a doctor setting that up in the Fijis. And so we're almost too late. To do any kind of regulation in this country just encourages the innovators to go outside of the country. So the question is, what can be done in this country at this point, given that it's already, from my perspective, too late?
Well, it's definitely not too late in my view. It's early. It feels like it's late, but we're at the very, very early stage. I think they will advance more faster than we think, but there still is a lot of room, I believe. And a lot of this stuff that's happening in the Bahamas is extremely experimental, extremely unproven. Everybody here, I certainly discourage you from doing it, and it's may very well not be safe. But at some point in the future, these technologies are going to mature, and there's a there with whether it's telomere extension or just slowing the process of cellular aging, which can be done very effectively now in roundworms and mice, and it's through kind of creating a synthetic starvation state, and they can be done through calorie restriction or by drugs that generate that kind of response. But you're right that in this book, in Eternal Sonata, there's a ship on the high seas where these revolutionary scientists go so they can do the experiments that they want unfettered by national regulation. But at the same time,
not to give away the plot.
Yes. But at the same time, what we're talking about is life. It's human life. And at some point, we as a species are going to wake up and realize that we need to have a framework to think about this. And my feeling is that's why I write these books. That's why it's so important for me, at least, to have conversations with people like you, is that it's up to all of us. This is our species. We need to be having these conversations. We need to be pushing forward and speeding up the maturation process so that in this race between thinking about how we apply the values framework and the science racing ahead, the former has at least a fighting chance.
Well, Jamie, we thank you for writing the novel. We thank you for stimulating the conversation. And I know that you're going to continue stimulating it. You're going to go around the country and talk about it. And I hope you're going to give us another one in a year or two.
Good.
So thank you all for coming. Jamie is going to hang around.
Yes.
So come up and ask him your question.
Thank you.